Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered if we could zap away depression faster than ever before, maybe even with a tiny brain implant? Well, this new study takes us a step closer to answering that. Imagine a powerful tool that could help people battling severe depression get better, not in weeks, but maybe in days. That is the big idea behind this fascinating research. We're talking about a condition called major depressive disorder, or MDD, which can be incredibly tough to treat, especially when other methods haven't worked. This is a huge problem, affecting so many people and really impacting their lives. And sometimes depression shows up alongside other conditions like epilepsy. It's like these conditions gang up, making things even harder. Now, normally treatments for depression take time to start working. We're talking weeks, but what if we could speed that up? Researchers are exploring different ways to stimulate the brain to help lift mood. One promising approach is a technique called transcranial magnetic stimulation, or TMS. They've even found that doing many sessions in a short amount of time, called accelerated TMS, can work faster. But even with these accelerated methods, the effects sometimes don't last. So scientists are always looking for ways to make these treatments even more effective and durable. And that's where this particular study gets really interesting. They're talking about using iTBS, that is intermittent theta burst stimulation, but not from the outside of the head with TMS. They're doing it from inside the brain, invasively, right into a part of the brain called the dorsolateral prefrontal cortex, or DLPFC. And they're doing it in a person who has both really tough epilepsy and major depression. This is essentially a proof of concept study, meaning they're testing if the idea even works. So let's meet our participant. He is a 35-year-old guy who has been dealing with epilepsy that just wouldn't go away, even with medication. Because of this, he was admitted to the hospital for something called intracranial monitoring. Basically, they implanted tiny wires directly into his brain to get a super close look at what was happening to pinpoint where his seizures were starting. On top of his epilepsy, he was also struggling with severe depression, anxiety, and other challenges. He tried many treatments for both his epilepsy and depression, but nothing had really stuck. So, he was in a pretty tough spot, but this hospital stay presented a unique opportunity because he already had these brain sensors. The researchers could try something new. They decided to use those implanted brain wires to deliver the ITBs directly to his left DLPFC. This is a brain area known to be involved in mood regulation, the same area often targeted by non-invasive TMs. They delivered a massive 20 sessions of this stimulation over about 10 hours, doing it while he was awake and even while he slept. This is a really accelerated protocol packed into a single day. Importantly, they made sure the stimulation wasn't happening anywhere near where his seizures were coming from to keep everything safe. The patient wasn't told exactly when the stimulation would happen, which helps reduce any psychological effect, like the placebo effect. And guess what? The treatment went smoothly. No seizures, no weird feelings. And pretty quickly, the patient started noticing a difference. He mentioned feeling a bit better after just a few sessions. But the real magic happened after he left the hospital. Within a day or two, he reported a massive shift. He felt more decisive, more focused, more optimistic, and just generally happier. His suicidal thoughts and troubling intrusive thoughts completely vanished, and he felt calmer than he had in ages. His mother even noticed the change, describing him as rationally positive and more emotionally stable than she'd seen him in decades. His own psychiatrist confirmed a remarkable improvement and remission of his depression. This improvement lasted for quite a while. Even at the 9-week mark, he was doing much better. This is really promising because it shows the effects weren't just fleeting. Unfortunately, like with many depression treatments, the effects weren't permanent. By 18 weeks, his depression symptoms had returned. This did happen after some changes in his epilepsy medications and a restart of cannabis use, which are important factors. But it highlights that while this treatment can be incredibly fast-acting, durability is still a question. Now, the researchers didn't just stop at the mood improvements. They also looked at what was happening in his brain while this was all going on. They used those implanted wires to record brain activity. One of the things they measured were cortical evoked potentials, or CCEPs. Think of these like little electrical echoes in the brain that show how different areas are connected. When they stimulated his DLPFC, they saw changes in these echoes, especially in the areas closest to the stimulation. They found that the early parts of these brain echoes, which are thought to represent direct connections, actually got stronger right after each stimulation session. This suggests the stimulation was directly affecting those local brain circuits. Interestingly, over time, these early echoes tended to get weaker between sessions, but the late parts which represent more complex brain pathways, showed different patterns. They also looked at the brain's overall electrical rhythm, called local field potentials or LFPS. During the breaks between stimulation bursts, they saw changes in the brain's brainwaves. Specifically, there was more activity in the theta and delta frequency bands, which are slower brainwaves, and less activity in the beta and gamma bands, which are faster. This pattern is thought to be a sign of the brain adapting to the stimulation. Perhaps one of the most surprising findings was what happened in the hippocampus, a part of the brain important for memory and mood. They noticed that neurons in the hippocampus actually became more active after the stimulation. This is significant because the hippocampus is also involved in conditions like PTSD and even epilepsy itself. So, what does all this mean? This study is a really important first step demonstrating that you can deliver a full course of ETBs directly into the brain, and it can lead to rapid and significant improvements in depression. This approach could be a game changer for people who haven't found relief with existing treatments, or for those who are already undergoing brain surgery for other conditions. Imagine if implants designed for epilepsy or Parkinson's could also deliver this depression treatment. Scientifically, it gives us incredible insights into how the stimulation works. We're seeing direct evidence of how these brain circuits are being modulated, not just in the targeted area, but also in connected regions like the hippocampus. They're seeing how different brainwave patterns change and how individual neurons respond. Of course, this is just one person, so we need to be cautious. It is a case study, not a big controlled trial. The patient knew he was getting a new treatment, and even though they tried to blind him to the exact timing, there is always a chance of expectancy effects. Plus, other life events happened during the follow-up period that could have influenced his mood. Like good news about disability benefits and becoming a father, though his mood improvement was noted before these major events. He also had changes to his epilepsy medications and resumed cannabis use, which are important variables. The big takeaway here is that this research shows real promise. It opens the door to developing new, faster, and potentially more targeted treatments for depression. Future studies will need to confirm these findings in larger groups of people, explore how to make the effects last longer, and figure out the best way to deliver this kind of treatment. Could we one day have implants that not only help with epilepsy, but also actively improve your mood? This study suggests that might be a real possibility. What do you all think about this kind of brain stimulation? Let me know in the comments below. If you found this interesting, please give this video a thumbs up, share it with your friends. And don't forget to subscribe to RUBIN'S Mind Lab for more fascinating science breakdowns. Thanks for watching, and I'll see you in the next one.